Welcome to another episode of Everything Electrical with Pat. Today we'll discuss the difference between AC and DC power. If you've spent any time around electrical systems, you've heard the terms AC and DC thrown around constantly. But what actually separates them? And why does it matter which one you're working with? Whether you're a student, an apprentice, or a homeowner trying to understand your electrical setup, this video breaks down the real differences in plain, practical terms. Let's start simple. DC direct current flows in one direction only, from positive to negative, in a steady, constant stream. Think of it like water flowing one way through a pipe. No reversing, no pulsing, just a steady push. You will find DC in batteries, solar panels before they are inverted, fuel cells, and DC generators. And here's the thing most people don't realize. Most of your electronics actually run on DC internally. Your phone, your laptop, even the circuit boards inside your TV. Now, AC, alternating current, is different. Instead of flowing one way, it reverses direction periodically, oscillating back and forth in a sine wave. Most grids do this 50 times a second, 60 in places like the US and parts of the Americas. AC is what comes out of your wall socket. It's generated by alternators at power stations, coal, hydro, nuclear, gas, and it's the standard for electricity distribution almost everywhere in the world. So why does AC dominate the grid? It goes back to the late 1800s, a rivalry historians call the War of Currents. On one side, Thomas Edison, backing DC. On the other, Nikola Tesla and George Westinghouse, backing AC. AC won, and it came down to three big advantages. 1. Transformers can step AC voltage up or down efficiently. That's essential for sending electricity over long distances without massive losses. 2. Higher transmission voltage means lower current, and lower current means far less energy wasted as heat along the way. 3. AC generators, alternators, were simpler and more robust to build than the early DC generators of the time. Let's put it side by side. AC reverses direction, DC stays constant. AC comes from the grid and generators. DC comes from batteries, solar panels, and fuel cells. AC is easy to step up or down with a transformer. DC historically wasn't, though that's changing with modern HVDC technology. And day to day, AC powers your home and industry. DC powers your electronics and vehicles. Here's where it gets practical. In your home, the power coming in is AC, but every charger and adapter you own is quietly converting that to DC before it reaches your devices. In industry, AC motors dominate because they are durable and easier to maintain, and with variable speed drives, they now get the same precise speed control that used to be a DC-only advantage. Solar panels generate DC, so if you're feeding that into your home or the grid, you need an inverter to make the conversion. That's a core part of any solar installation. And in electric vehicles, the battery stores DC, but charging stations and onboard systems are constantly converting between AC and DC depending on whether you want a slow AC charger or DC fast charger. So which one's better, AC or DC? Neither. They are not competitors anymore, they are partners. AC dominates large-scale transmission because of how efficiently it moves power over distance. DC runs your electronics, your batteries, and is increasingly showing up in high-voltage DC transmission lines at data centers, where it can actually outperform AC. Modern power systems are a hybrid of both, and now you know exactly why. Thanks for watching. Get more info on everythingelectricalwithpat.com.